Have you ever stopped to think about the words we use for our feelings? Why do we talk about being stuck in a rut or a feeling of flowing with joy? Well, we're about to dive into a totally new way of thinking about your mind. Forget just chemicals and signals for a second, and imagine it as a dynamic geometric landscape. It's a single, powerful idea that might just connect everything from pain and happiness to consciousness itself.
I mean, really think about that. We all use these words. Stuck, trapped, flowing, released. It's not an accident. It's a deeply universal human experience. And that's the central mystery we're going to unravel today. Why those metaphors might not be metaphors at all, but a description of something physically real happening inside your brain. So, to get to the bottom of why pain feels stuck and relief feels like a flow, we have to introduce a new fundamental currency for the mind. We're not just talking about neurons firing here. We're talking about the tension they hold and the tension they release. Let's get into it. And that currency is called neural strain. The easiest way to think about it is as any kind of unresolved tension. You know that feeling when you're about to sneeze but just can't? Or when you're waiting for a super important text message? That's strain. It's a blocked action, an unfulfilled prediction, a buildup of energy. This right here, this is the core concept that unlocks everything else. And boom, this side just lays the whole theory out perfectly. Pain, especially that deep psychological kind, is just a neural strain that gets trapped. It has nowhere to go. And happiness? Well, that's the feeling of that exact same strain being successfully resolved, of it discharging or just flowing smoothly. It's not about the strain itself, it's all about the dynamics of its movement. Okay, so if happiness and pain are all about the flow of this strain, how in the world does the brain actually manage that flow? Well, it turns out it has this incredibly sophisticated microscopic plumbing system. And the real heroes of this whole story are the neural receptors on your brain cells. Now, these aren't just simple on-off switches. No way. They are the intricate valves, the gates, and the dams that literally direct the flow of neural strain. They decide where it goes, how fast it gets there, and whether it gets trapped or set free. Now, what's really cool is how these different receptors all have their own specific jobs, kind of like a city's infrastructure. You've got AMPA receptors, which are like the superhighways spreading strain fast and wide. Then you have NMDA receptors, which are more like elevators, slowly integrating that strain across different layers of the brain to create meaning. And of course, GABA receptors act like dams and gates, containing the flow to make sure things don't get out of control. So this setup gives us two basic ways that strain can move around. You've got this fast horizontal flow that spreads locally, kind of like a ripple in a pond. And then there's a slower, more deliberate vertical flow, which moves up and down the layers of the cortex, transforming all that raw tension into something meaningful. For your brain to work properly, you absolutely need both. So how does all this microscopic plumbing add up to what we actually feel? This is where it gets really interesting, where we start to see our emotions not just as words like sad or happy, but as dynamic, ever-changing shapes formed by this flow of strain. You see, an emotion isn't a static thing. It's a two-part process. First, there's the buildup, the strain potential. That's the tension we feel as anxiety or anticipation or hope. But then comes the second part, the strain kinetics. That's the actual movement of that tension. The speed and the direction of that flow is what we experience as the emotion itself. I absolutely love this quote from the source material because it just nails it. Happiness isn't some destination you arrive at. It's the feeling of progress. It's the direct experience of tension moving, resolving, and clicking into place. It's the feeling of successful flow. Okay, so now let's zoom all the way out, because this framework doesn't just explain our feelings, it gives us a brand new way to visualize the very structure of consciousness itself. Here's the really big idea. Consciousness isn't a thing you can find in one spot in the brain. It's a property of the whole system. It's this vast, mind-bogglingly complex and interconnected landscape that allows that neural strain to travel, explore, and resolve itself in countless ways. In other words, consciousness is the size and shape of that landscape. So if that's true, what happens when we lose consciousness? Well, the landscape literally changes its shape. When you're in a deep sleep or under anesthesia, that vast, sprawling landscape actually collapses into a much smaller, simpler state. The space for your mind to explore just shrinks. A seizure is a totally different kind of geometric change. In this case, the landscape doesn't collapse, it shatters. It breaks apart into all these disconnected regions that can't talk to each other, which leads to all that chaotic, unsynchronized activity. And in a vegetative state, the geometry gets stuck. The brain's activity becomes trapped in one small repeating loop within the landscape, completely unable to explore or move on. It is the ultimate, tragic form of being stuck. But what about dreaming? This is so cool. According to this model, dreaming is not unconsciousness at all. The landscape is still vast and complex, but the source of the stream, the thing creating the tension, it shifts. It's no longer the outside world, it's our own internal memories and emotions. It's consciousness turning its gaze inward. Okay, so buckle up, because this is where the theory takes a really wild and truly beautiful turn. This isn't just a metaphor or a conceptual model. It has deep, profound connections to a powerful branch of abstract mathematics. The theory proposes that this whole landscape we've been talking about, the entire space of all possible brain states, can be formally described as something called a moduli-space. Now, I know that sounds incredibly complex, but you can just think of it as a mathematical map of a universe of possible shapes and how they can transform into one another. Our mind, in a way, is one of those universes. In the language, the actual mathematical tools to explore these mental geometries comes from the groundbreaking work of mathematicians like Maryam Mirzakhani. Her work on understanding flows and paths on complex curved surfaces gives us the exact toolkit we need to start analyzing how our mental states evolve over time. So, what's the big payoff for thinking this way? Well, this geometric view gives us real, concrete, testable predictions. It suggests that consciousness isn't about how much your brain is firing, but about the size of the landscape it has available to explore. It predicts that psychedelics might work by literally expanding and reshaping that landscape, and that disorders of consciousness are really just the landscape shrinking or getting stuck. And all of this brings us right back to a final thought for you, right here, right now. If your mind really is a dynamic, geometric shape, what does it look like in this very moment? Does it have volume, curvature? Is it flowing freely, or is it getting caught somewhere? What is the shape of your consciousness right now?